Let's talk in detail about some of these monadic functions. First, changing the pixel type. Quite useful frequently to convert an unsigned integer image into a double image. So what we're going to do is take input pixels in the range 0 through 255, and these are integers, so they've got values 0, 1, 2, 3, and so on. And we're going to map them into the range of real numbers between 0 and 1. And we can represent that mapping by a graph which is shown there on the right. Conversely, we could convert double precision images into uint8 images. So what we want to do now is to take pixels in the range 0 to 1 and map them into integer values in the range 0 to 255. And again, we can represent this mapping graphically. Note that in both cases, the mapping is a straight line that passes through the origin with a gradient of 1. We could also change the brightness of the image, and there are a couple of ways that we can do that. One way is simply to add a constant positive value to all of the grey values within the scene. So f of x is the input value x plus the value of a quarter. And if we represent that graphically, we see this shape here. And what happens is that some of the pixels are going to exceed the value of 1. So we apply what we call a saturation. We don't allow them to be greater than 1. So our line has got a kink in it. If we apply this transformation to the Mona Lisa image, we can see that indeed the image has become brighter. Another way to increase the brightness of the image, often referred to actually as increasing the contrast of the image, is to multiply all the grey values by a constant. So in this case, we're going to multiply all the grey values by the value of 2. And we can see if we represent this graphically again, the slope of the line now is steeper than it was before. This line now has got a steepness, a gradient of 2, and the saturation problem is more pronounced now. So there are a lot of values which, if we applied the function 2x, would have a value much greater than 1. We've had to limit those or saturate those to the maximum value of 1, which we have when we represent images in double precision numbers. What we can see now when we look at the image, we can see that it is indeed much more contrasty, but we can also see some areas where the pixels have become saturated. A simple function like this, 1 minus x, produces a negative image. So this is graphically a line with a slope of -1, and what happens here are bright input pixels become dark in the output image and vice versa. I mentioned earlier the technique called posterization, which you can often find in pop art. And what we do is we limit the number of possible output brightness values that there can be. We quantize it, if you like. So in the image shown here, what we've allowed are only 4 possible output grey values. So this staircase mapping converts a continuous range of input grey levels to one of 4 possible output values.